binomial tree. So now we are going to discuss about binomial tree. How do you put a price on something whose future value you genuinely don't know? That's the entire problem behind pricing an option. Long before complicated formulas took over, traders solved this with something surprisingly simple. Draw out every possible path a stock price could take, step by step, like branches on a tree. Then work backward to figure out what the option should be worth today. That's a binomial tree. I will show you exactly how it works step by step with no scary maths required. A binomial tree price an option by mapping out possible future price path, then working backward to today's fair price. So now the core idea, just two outcomes. Here's the simplifying trick that gives the binomial tree its name. At each step in time, we assume the stock price can only do one of two things: go up by some amount or go down by some amount. That's it. Two branches at every step. Simple example, stock is at 100 rupees today. In one step, it either goes up to 110 rupees or down to 90 rupees. That's the one step binomial tree. Just two possible outcomes. Now here is the real power. You can chain this step together over and over so that after several steps, you might get a whole branching web of possible future price, a genuine tree of outcomes. Build a simple one-step example. Let's build a simple possible version so the logic is crystal clear. Say a stock is at 100 today. In one period, it will either rise to 110 rupees or fall to 90 rupees, nothing in between. Now, say you own a call option that gives you the right to buy the stock at 100 rupees. This is called the strike price. If the stock rises to 110 rupees, your option is worth 10 rupees. You can buy at 100 and it's worth 110 rupees. If the stock fall to 90, your option is worth 0. Why should you use your right to buy at 100 when the market price is only 90? So the option have two possible futures, value of 10 or 0. The whole binomial tree method is about figuring out, give those two possible payoff, what's the option worth today. The key trick, risk neutral probabilities. Here is the part that triple people up. So let's go slow. You might think just figure out the real world probability of the stock going up versus down and average the payoff, but that is not what the binomial method actually does. And here why. Instead, the method uses something called a risk neutral probability, a mathematically constructed probability that is not about predicting the real future. It's specifically chosen so that if you use it, the stock expected return would exactly match a risk-free rate of return. Why does this matter? Because it let you build a perfectly hedged, riskless portfolio, combining the option with some amount of the actual stock that has the exact same payoff no matter which direction the stock moves. If the portfolio has zero risk, it must earn exactly the risk-free rate. Otherwise, someone could make free money through arbitrage. That single idea, no free lunch, is the entire mathematical engine behind the binomial tree method. Working backward through the tree. Once you have the risk neutral probability, pricing the option is mechanical. Start at the first step. The option payoff you already know, like our 10 rupees or 0 example. Take the risk neutral weightage average to those payoffs. Discount that average back to today using the risk-free interest rate. The result is the option fair value today. For a tree with many steps, you simply repeat this process, working backward one layer at a time, from the final branches all the way back to today until you have collapsed the entire tree down to the single starting price. Why use a tree at all? What it's good for? You might wonder, why not just use a single formula like the famous backscore model? Instead of building this whole tree, two big reasons the tree approach still matters. Reason one, it handles early exercise. Some options called American options can be exercised at any time before expiration, not just at the end. A tree let you check at every single node whether exercising early is worth more than holding on. A single formula can't easily do that. A tree naturally can. Reason two, it's intuitive and flexible. You can see step by step exactly where the options value come from. It also adapt easily to more complex features like options with unusual payoff structure where a clean formula might not exist at all. The trade-off, more steps means more accuracy, but also more computation. As you add step, a binomial tree actually coverages towards the same answer a continuous formula like Black's code would give. And we will discuss about the back, like today we are discussed about the binomial tree. So next we will discuss about Black's codes. So we will get to know more about what exactly it is and how it works and nature in our upcoming videos.